So, as said, introduce myself a little bit. I'm Tim Logue. I happen to be the president and chairman of the board of the PTC. I noticed that a lot of you are not members. I encourage you to consider membership. We've got a membership table down in the top of bar area, and you can talk to them about the benefits of being a member of the PTC. We're always innovating to get the message out. We're really encouraged by the number of people we're seeing show up here at the hub. This is a new concept for us, but it looks like it's going gangbusters, so we're very pleased. What I want to talk to you today about, where's my presentation, is, and also to explain where I'm coming from. I'm a sales and marketing guy. I'll tell you when I'm ready. Yeah, you can go ahead and pull up the first page, yeah. You just had it up. Hold on one second. Oh, no. Let me do this. So unfortunately, we don't have a presentation, but I'm going to grab mine to remind me of the points I wanted to hit. And then if you would like to get that presentation or a fuller presentation that's derived from, I'll be happy to do that. So give me 1 second. I did do my homework. So anyway, again, thanks. I'm Tim Logue. As said, I'm a big shot here after 40 years of trying. Anyway, an overnight success after 40 years of coming to this conference. But if you're not familiar with Thales Alenia Space, it's a French-Italian space company. It's arguably from a space standpoint, the largest in Europe. We're most famous and well known for doing a lot of work on the International Space Station and building satellite constellations. So you'll see where that plays in here. So the Iridium constellation, which many of you know about, the satellite telephone system, and O3b, which is a broadband system, which has been here and made presentations often at PTC, and Globalstar, which is like Iridium, a satellite telephone company. We built all of those constellations, so more than 100 individual satellites between those three constellations. What I want to talk to you today, though, is about an issue that's very present in the minds of everybody in the satellite industry, and that's 5G. And most of what you've heard about 5G and satellites has been about how 5G is going to take away critical frequencies from the satellite industry. And that's been what I would call World War I. And I think we're approaching a truce. I think we're approaching November 11th on that particular war after the conclusion of the just concluded WRC in Egypt 2 months ago. I think what we're looking at now, though, is a different approach, and that's what I want to present to you here. The classic approach, if you will, the business model that's been followed by the satellite operators and the satellite industry towards mobile network operators is to say, oh, Mr. Mobile Network Operator, if you want to provide service on remote communities in Southeast Asia or on the islands or even in the United States, we'll provide you backhaul. What's backhaul? You put up a cell site in a rural area, you pick up the signals from there, and since it's too expensive to run fiber or microwave to that area, you pump it up to the satellite and it gets dropped to a central operating location in a major city usually. And that has been the model for several years. What we're suggesting is that the advent of 5G, which is coming on to us very quickly, is an opportunity not to provide interconnection, which has been what's been offered, but rather to offer integration. And why is there a difference there? The difference from the mobile network operator's standpoint is that they'll be able to get more functionality out of it. Rather than just being given a bent pipe, we'll be able to, the satellite operators and providers will be able to provide more of the functionality that they really want to see in their mobile network operator and to be able to offer to their customers, their retail customers. If you had this presentation, you'd see lots of nice diagrams, but basically we can divide the 5G market up into a number, or say 3 categories of services, 2 of which are very relevant to satellite services integrating into the mobile network. The first one is obviously the one that we all think about in urban areas like this, dense urban areas. You can offer 5G services and you have no need for satellite backhaul of any kind because fiber networks are already there. You can do microwave over short distances. That's not a problem. But there are other areas where you have mobile services where you're talking about to trains and buses, maritime settings where you might want to, like a cruise ship or something, where you might want to be able to transition and provide land-like mobile services on a big cruise ship, and also within buildings and in villages in really rural areas, not necessarily deep rural areas. The third area is really outdoors, away in the wilderness, and in what my colleagues call deep rural. And that's an area where satellite services can be particularly useful. For those of you who are not satellite providers, though, or familiar with those kinds of services, there's an important difference here that I need to point out. There are constellations like the ones I cited that fly at a relatively low altitude above the Earth. And then there are the classic satellites that we all think of, geostationary satellites. And those, that's all right, I don't have any slides. Couldn't have turned them anyway. And there are the geostationary satellites that are at 36,000 kilometers above the Earth. There's a key, those are great for a lot of reasons and have been great for 50 years. The problem in 5G is it's less tolerant of the lag in the signal getting up and down. So what we're suggesting is that you set standards that integrate satellite services more completely into the mobile network so it's almost invisible, that you rely heavily on these LEO satellites that are closer to the Earth. In fact, we could foresee a time when a perhaps dedicated, specialized type of LEO constellation is launched so that it provides the functionality, the switching, et cetera, that you need for terrific 5G interconnection. The other things you would be looking for from a satellite services provider to be able to integrate is you want to minimize or even eliminate potential changes to user equipment. You don't want to have the old, for those of us who remember, to access, you could have a cell phone that was like this, but if you wanted to include an Iridium connection to it in the first generation, it was like a brick. I mean, you put it in there and it gave you the extra power and battery life and everything, but it really wasn't very practical on an ongoing basis. You also want to minimize impacts to the mobile network operators' networks. So you want to make it easy to integrate the satellite services. I think what I'll kind of sum up, because I think we're getting towards the end of this, and I'll be happy to answer questions to the extent I can, is that what we're imagining is a kind of a 3-layer system. At the ground level, you've got the mobile network operator. He may, in some remote areas, have a satellite earth station that uplinks to either the LEOs or the GEOs, probably more likely the GEOs, for traffic that's not as time-dependent and sensitive to the delays, the millisecond delays that you get going to GEO and back down. And then you've got a LEO network that's potentially interconnected within itself with inter-satellite links to provide the immediacy that you're looking for in 5G communications. So this is basically my pitch. We hope that our company particularly has dedicated resources to working with the through the ITU system to make sure that there are standards that the satellite industry and the satellite services people can live with, and that in fact we provide useful additional functions to the mobile network operators. So that's my pitch. So anyway, I'm happy to take questions to the best I can. Happy to take, and also, as I said, get you in touch with the experts and provide copies of either this presentation that didn't make it here or to the fuller presentation that was behind it. Yes, ma'am.
Something that I'm curious about your commentary is about the MEO connectivity. It's been supporting the islands for many years now.
Right, from O3B particularly. Right.
And there are O3B and POWER
Right. Well, the difference is one has to understand there's, it's a, how would you want to say it, a slope of the time delay. If you walk out here and you have a satellite telephone, if you want to talk to a LEO system, you need X amount of power, and the time delay is Y. And that satellite may be as low as, I think Iridium is 800 kilometers, and whatever that translates into miles. A MEO system like you cited O3B, I think they're operating at 10,000 kilometers, so you get a bit more delay in that. But if you're tolerant of that, that's fine. And then if you go to geostationary orbit at 36,000 miles, I'm trying to remember what the millisecond delay is. Do you remember what it is, Chuck? To geo. 600 milliseconds? Okay, round trip. Round trip, 600 milliseconds up and back to geostationary orbit. So it's a question of trading off the sensitivities of your system to the network you're operating with. And you might wonder, why are they at different altitudes? Is because of the radiation belts and where you can, kind of safely park or relatively safely park a system. Like O3B is kind of not exactly in the Valley of Death, but it's not a good neighborhood. Iridium's much lower and is kind of a cleaner environment from a radiation standpoint. And then you get the geostationary orbit, and that's fine, it's clear, but you're going a distance is what it amounts to. Did I answer your question? Okay, other questions? Sir?
What about the role of nanosats in the Internet of Space things? Areas that are required
Yeah, I think there's a lot of terminology that I'm not even completely conversant in. I mean, my company builds through a subsidiary, 50 kilogram satellites. There are others that are even smaller. Again, you've got a trade-off there where you've got the amount of power that you can, if you had a satellite that was, about this size, which would be, we're at about 6Q, huh? 6U, which a U is just a unit of measurement that's become standard in the industry. This is about a 6U. That's great, but there's only so many watts you can put through that. So to get an effective signal to Earth, I've got to fly pretty low. And that means the lifetime of that satellite may be relatively short because it'll get some atmospheric drag and gravitational effects. So there's trade-offs to be done there. You can put this up very cheaply, and you can put a lot of them up fairly cheaply. But there's trade-offs to be made with something like an O3B type satellite that's around, I want to say 1,000, not 1,000 kilograms, 1,000 kilograms, could it be? It's like 1 metric ton, I think, basically. So it's a heavier satellite, but you can also, out of that satellite, handle greater power. It's like a 1 kilowatt, 1 ton satellite. A geostationary satellite, on the other hand, might generate upwards of 20 kilowatts, so it's producing a lot of power, and can have a lot of capacity. So there's trade-offs there between capacity, power, and what you need to close that all-important radio signal to the Earth. And just to confuse things, that varies based on the frequency band you're using. One of the fights, to go back to that fight in World War I in the satellite versus 5G world, has been that the 5G folks want to use C-band, which has been a traditional use since the 60s by the satellite community. It's got one big value, is that it can operate in tropical zones, subtropical zones, pretty reliably. But if you start moving up in frequencies, Ku band is generally fairly good as well, but we're being pushed into higher frequencies where those radio signals are bouncing off raindrops if they're too heavy. So this is the challenge that we're going to face, but it seems to be the direction we're being pushed. So, other questions? Okay.